Hey everyone, welcome back to yet another scintillating conversation on the Fourth Industrial Revolution, and we're going straight to the source. The Fourth Industrial Revolution and 100 Years of AI, 1950 to 2050, by Dr. Alok Aggarwal.
Definitely. It's a really interesting look at where we are now and how we got here.
Right, we always hear Fourth Industrial Revolution thrown around, but what does that even mean? Feels like we're living it, but sometimes I need that step back, you know?
Absolutely. And that's where this book comes in handy. Dr. Aggarwal does a great job of breaking it down.
Absolutely. And he kicks things off with a brilliant quote from Thomas Edison. I have gotten lots of results. I know several thousand things that won't work. Just imagine that mindset. It's all about persistence and learning from every setback.
Exactly. And then he deep dives into these 8 vital characteristics during these industrial revolutions, which really shows how these massive shifts are built on both breakthroughs and failures.
Truly. So today we'll explore the first 4 traits, how a single invention can spark new infrastructure, how certain inventions explode in popularity, the power of interconnected innovations, and the long road it takes for them to become mainstream.
And then, next time, we'll dive into the other 4: societal adaptation, wide-reaching impacts, the winners and losers, and the pivotal role of governments. Let's jump right in.
Definitely. So first up, data. Everywhere you turn, it's all about data.
Yeah, the way he lays it out with data generation, transmission, and refinement. Then, how it's used. It's like, whoa, this is the foundation of everything we're talking about.
It really puts things into perspective, right? And then there's AI, artificial intelligence. It's like AI is suddenly everywhere we look. He calls these systems the motors of our time, and I can see why.
Absolutely. But what's interesting is that the idea of AI isn't new. It's been around since the 1950s, but something's different now.
Absolutely. We've had these huge leaps in technology, the computing power we have now, unheard of back then, and the massive amounts of data available, plus the algorithms are just light years ahead of where they were.
Exactly. And all of that combined has made AI commercially viable on a whole new level. It's not just a concept anymore. It's here. It's real, and it's changing everything.
And AI is just the tip of the iceberg. There's so much more, from the Internet of Things to climate tech and blockchain. Speaking of blockchain, I find that especially fascinating.
Right. It feels like every day there's a new potential use for blockchain. It's not just a buzzword, it represents a fundamental shift that's set to change how we interact with the world.
Exactly. Like the Internet of Things, everything's getting connected. My refrigerator can probably order groceries soon if it doesn't already. But seriously, when he talks about our homes getting smarter and cities becoming more efficient, it's like, are we living in the future already?
In a way, yeah. And this idea of decentralization, that's where blockchain comes in. Most people, they hear blockchain and think Bitcoin, but it's so much bigger.
That's what I find so interesting. The possibilities. Imagine supply chains and even voting systems becoming more secure, bringing a whole new level of trust and transparency.
Exactly. And that potential for disruption. That's what makes this revolution so different. It's not just about making things better. It's about completely changing the way things are done, like with the metaverse or robotics. We're on the edge of sci-fi becoming reality.
It really does feel that way. Remember when virtual reality was just a game? Now they're saying it'll change how we work, how we learn, even how we have fun. It's wild.
And while we're diving deeper into the digital world, robotics are getting more and more sophisticated. We're not just talking about robots building cars anymore. We are talking about surgery and ocean exploration.
And what's powering this robotic revolution? 3D printing. Remember when it was mostly for prototypes? Now we're talking about printing medical devices, houses. It's incredible. It's like anyone can be an inventor now.
It really is democratizing, and we're seeing that in healthcare too. Gene editing, personalized medicine, and using AI to develop new drugs. The pace of discovery is accelerating.
It's really exciting, but also a bit overwhelming. We're reaching the limits of what our current tech can handle, and that's where next-generation computing comes in, right?
Exactly. Quantum computing, new materials like graphene, even harnessing light with photonics. This is where things get really futuristic.
I'm trying to wrap my head around quantum computing. It just seems so out there. But the potential, if it delivers what they're saying, that's a game changer.
Exactly. Dr. Aggarwal believes this next generation of computing could lead to breakthroughs in so many fields. Everything from medicine to climate change. It's about pushing the boundaries of what we thought was possible.
It's like you start thinking about the future, and it's exciting, but then it's like, whoa, where's this all going? What does it even mean for us?
That's the big question, right? How these technologies are going to reshape everything, not just our gadgets, but our societies, our relationships, everything.
It makes you think, are we just along for the ride? Or do we actually get a say in how this all plays out?
We're not passive bystanders. We make choices every day, investments in certain technologies, conversations about the future we want. Those choices matter. And that's why it's so important to have these conversations, to be aware of the potential downsides too.
It's about finding that balance, isn't it? The good and the bad, and making sure everyone benefits from these advancements, not just a select few.
Absolutely. It's a collective effort. We need open dialogue.
Absolutely.
Ever get this feeling like the ground is shifting under our feet? Technologically speaking, like it's not just new gadgets, it's like a whole new understanding of how things work is emerging.
That's a great way to put it. It's like those aha moments. Suddenly you see the world differently. Those massive shifts in thinking, the scientific revolutions. These revolutions aren't just dusty history, and understanding them is key to navigating the crazy changes happening right now with AI and technology in general.
Okay, so let's unpack this whole scientific revolution thing. Dr. Aggarwal leans on the work of Thomas Kuhn. He wrote this super influential book back in 1962, The Structure of Scientific Revolutions.
Yes, Kuhn's big idea was that science, it doesn't just move forward in a straight line. It's more like bursts of change, almost like earthquakes, you know?
Okay, I like that analogy. So picture this. Scientists are working within a certain paradigm. It's the accepted set of rules, theories, and the whole framework. But then, here come the glitches in the system. Kuhn calls these anomalies, basically stuff that doesn't fit the existing paradigm, no matter how much you try to make it fit. At first they ignore it, but these anomalies, they can pile up, and that leads to a crisis in the scientific community. Suddenly, nobody's quite sure what's true anymore.
That's where things get interesting. Out of this crisis, someone, or sometimes a whole bunch of people, come up with a radically new way of thinking, a new paradigm. This is the revolution.
It's like upgrading from, Windows 95 to something totally different, like a system that operates on quantum principles or something.
Correct, and the perfect example of this is the Copernican revolution. For centuries, everyone thought Earth was the center of the universe, until astronomers found observations that didn't fit that model. Then Copernicus comes along and says, what if Earth actually revolves around the sun? That's how these revolutions work. They shake things up fundamentally.
Exactly, and it wasn't just Copernicus. Galileo and others supported this sun-centered model, and eventually it became the accepted view. But even that model eventually hit its own limits.
Right? In the 1880s, physicists were baffled by experiments on light that didn't fit existing physics. Then came Einstein's theory of relativity, followed by quantum physics.
So we have these cycles. Normal science, anomalies, a crisis in the old ways, and then, bam, a new paradigm. So what's all this got to do with AI?
That's the exciting part. A similar revolution happened in the 1950s, paving the way for AI as we know it today.
A scientific revolution that led to AI? Was it like discovering some new element that suddenly made computers think?
Not exactly. It wasn't a physical discovery. It was a shift in how we thought about intelligence. Before the 1950s, intelligence was seen as something uniquely human, and machines were considered incapable of it. But researchers like Alan Turing challenged that view. Turing proposed the idea that intelligence could be simulated in machines. He basically said, if a machine can hold a conversation and you can't tell it's a machine, not a human, well then, for all practical purposes, it is intelligent.
Wow, that's such a mind shift.
Exactly. And that shift, that willingness to move beyond human-centric intelligence, that was the spark that ignited the AI revolution.
okay? So if we're following Kuhn's model here, I'm guessing this new paradigm of like machine intelligence, it had its own share of anomalies too, right? Those things that didn't quite fit.
Absolutely. One of the biggest head-scratchers in AI has been this. How do you replicate what we call general intelligence in a machine?
You mean like the kind of intelligence that lets us humans, adapt to all sorts of situations, learn new things, be creative. Basically, not just following a script.
Exactly. We navigate these complex social situations, understand abstract concepts, write poetry even. Getting machines to do that, whole other ballgame. And this is where those anomalies, they start popping up again.
So are you saying these challenges, this difficulty in creating truly general AI, they're like those anomalies Kuhn talked about? Are they pointing towards another potential paradigm shift in how we think about AI?
Now that's the million-dollar question, isn't it? To reach that next level of AI, the kind we see in sci-fi, we might need another fundamental revolution in our understanding of intelligence itself.
Okay, my mind's officially doing backflips now. Yeah. So we went from intelligence being this mysterious human thing to creating AI. But now, even that model is showing its limits. We're seeing the cracks in the foundation.
And just like those scientists grappling with the limits of the Copernican model, we're at a crossroads. Does the current AI paradigm keep evolving bit by bit? Or are we on the brink of a whole new understanding of what intelligence can be?
This is where I start getting a little, nervous, but also excited. Like, what could that even look like? Are we talking about computers becoming sentient, writing symphonies and questioning the meaning of life?
Well, it's definitely like venturing into what-if territory, right? But it isn't so much about, predicting the future. It's more about recognizing those blind spots we might have right now. We are being so focused on making machines think like us, we might be limiting what we can even imagine AI to be.
So instead of forcing AI to fit into our human definition of intelligence, we should be asking, what could intelligence look like on its own terms?
Exactly. What if, instead of trying to replicate human intelligence, what if we explore completely new models of intelligence, ones that aren't restricted by our biology or how our brains work even?
That's both exhilarating and kind of terrifying.
And that's what's so thrilling about scientific revolutions. It's all about embracing uncertainty, questioning everything we thought we knew, and being open to these radical new ways of seeing the world.
It reminds me of what Kuhn said about how these paradigm shifts, they often face a ton of resistance because people get attached to the old ways of thinking even when they're not working anymore.
Absolutely. And that resistance, it's completely understandable because it can be unsettling.
We're on the verge of another revolution in AI, and it's not just about faster processors or better algorithms. It's about grappling with huge philosophical and ethical questions. What intelligence is, what consciousness means, and what it means to be human as those lines blur.
Exactly. These are conversations we can't avoid. As we progress with AI, we must address these questions, not just in labs, but as a society. What are the benefits and risks, and how do we ensure these advancements are used responsibly?
It's like getting a sneak peek into this future that's bursting with potential, but also, potential pitfalls.
Exactly. Now, Dr. Aggarwal got this really interesting idea that all industrial revolutions, they share the same kind of DNA.
It's more than just new gadgets, right? It's like these aha moments when you realize, wow, this changes everything, the way we live, work, understand the world.
Right? Like imagine trying to explain a smartphone to someone from the 1800s.
Exactly. It's like the Cambrian explosion, that huge burst of new life forms millions of years ago. Each revolution creates a similar explosion of inventions, all feeding off each other, and the possibilities just explode.
So it's not just one invention, it's this whole chain reaction.
Precisely, he lays out three key things: new infrastructure, the Cambrian explosion of tech, and then what he calls the synergy of inventions.
Synergy of inventions. So it's like that saying, it takes a village to build a steam engine.
Exactly. Think about the first industrial revolution for a second. You need that base layer, that new infrastructure, which was steam power. And then you get the Cambrian explosion of tech, like James Watt's steam engine.
And because of that boom, factories everywhere, trains replacing horses, it's mind-blowing.
And here's the thing. Even Watt's engine, it wasn't a solo act. He was building on the work of Thomas Newcomen, who had this earlier, kind of clunkier version. It's like a relay race of innovation, like passing the baton.
Exactly. And that's where this whole synergy of inventions thing comes in, right?
Yes. And you know what else was being invented around the same time? The spinning jenny, the water frame. Those weren't directly powered by steam, but they were part of that whole manufacturing boom. They were made more efficient because of innovations like the Watt's engine. So it's like this chain reaction. One innovation leads to another, and suddenly, boom, the whole world's different. This brings us to the second industrial revolution, with which comes electricity.
Electricity. Oh man, try to imagine a world without electric lights or phones or computers. It became as essential as air. So if steam power was the infrastructure of the first industrial revolution, then electricity is the key for the second.
Okay, electricity is the foundation, but what's the Cambrian explosion invention this time around?
Think about it. What's everywhere but you never really see it? The electric motor. They are everywhere.
Exactly, but you only notice them when they break.
That's the worst. Okay, so we've got electricity as the new infrastructure, and electric motors become totally ubiquitous. What about that synergy piece? What else pops up during this second industrial revolution?
Think about it. The telephone, the telegraph, the internal combustion engine, none of those would be possible without those breakthroughs in how we understand and use electricity.
It's like this web of interconnected inventions, all coming from that one key technology. Okay, last stop on our historical tour before we get to the good stuff, the third industrial revolution. What's the big deal this time?
This one's a little more abstract. It's all about electronic communication and the CPU.
So basically everything from those giant computers they used to show in old sci-fi movies to the phone in my pocket.
Exactly. It all traces back to those early breakthroughs in computing.
The CPU started out huge, but then it gets smaller, more powerful.
More ubiquitous. Suddenly they're everywhere. Just like those steam engines and electric motors.
And that leads to this incredible explosion of different kinds of computers and gadgets and, well, everything we use today.
Precisely. And just like the first industrial revolution needed steam power, and the second needed electricity.
The third revolution needed new infrastructure, electronic communication networks, and the internet. So we've had steam, electricity, and computing. But here's the million-dollar question. What makes the fourth industrial revolution different, and what does it mean for us regular folks?
That's the really interesting part, isn't it? To answer that, we need to talk about data.
Data, huh? So instead of coal or electricity or whatever, it's all about bits and bytes, ones and zeros.
It's more like data is the air we breathe in this new revolution.
Okay, I think I'm starting to get it. But what are we breathing it with? What's the tool that makes data so powerful?
Well, think about what's been developing alongside all this data. Artificial intelligence. This fourth industrial revolution, it's all about data and what we can do with it thanks to AI.
So data is the foundation. AI is the engine. We're already seeing it, right? Self-driving cars, those movie recommendations that are somehow always dead on.
Exactly. And just like those other revolutions had their Cambrian explosion of new tech, we're about to see an explosion of AI applications. It's kind of mind-blowing when you think about it. AI diagnosing diseases, personalizing education, even creating art and music.
Okay, what happens to artists, to musicians, if AI can do what they do?
That's the thing about these revolutions, isn't it? Everyone creates challenges and opportunities. The key is understanding how these changes work so we can, make the most of the good stuff while minimizing the risks.
So with this fourth industrial revolution, we've got data as the infrastructure, AI as the engine, and just like the others, we're starting to see that synergy of inventions, right? All these different technologies kind of converging.
And that's what makes it so exciting. It's wild, right? Like every day it feels like bam, new phone, new app, new headline about AI that's going to change the world. Like we're living in the future already,
It's funny you say that because it's kind of true, but also not really. It's weird, right?
Even huge inventions, things that seem like they change everything overnight, actually take like decades to really matter.
Yeah, exactly. It's counterintuitive for sure. I mean, look at us. We're all about instant gratification these days, but history's got a funny way of proving us wrong. Remember steam locomotives?
Oh yeah, I get it. Even though trains seem kind of boring now, I can only imagine what people thought back to what was it? 1804, when that first steam engine got going.
1804. Yep, revolutionary, for sure. But here's the thing, it wasn't like invention, instant train travel for everyone. It took a long time to actually change transportation. To make it work, you needed everything. Thousands of miles of tracks, signaling systems, stations, the whole setup. It wasn't until the mid to late 1800s, about 60 years after the first engine, that trains truly became the go-to for moving goods around.
60 years. It makes you think about what we're using now that'll still be trying to figure itself out in 2084. But it couldn't have just been the tracks, right? I mean, 60 years to lay down some rails, there's got to be more to the story.
Oh yeah, for sure. Like one big one is just straight up money, just like with the train thing. Any new tech usually needs a whole ecosystem to exist, and that ain't cheap.
Right? So it's like inventing the thing is just step one. It's all the stuff around it that really adds up.
Exactly. The digital revolution is a great example. We think of the internet as instant, but someone had to lay millions of miles of broadband and fiber optic cables to make it possible. These massive, complex projects take decades, even today. And what else slows things down? People being people. Companies, governments, even regular folks. We get used to doing things a certain way. We put time and money into those ways.
The old don't fix what ain't broke mentality.
Exactly. Imagine you're a big company that just invested heavily in the latest gas-powered tech, only to hear that electric is now better and more efficient. Are you going to switch right away, even if it makes sense long-term? Probably not, especially with so much already invested in the old system.
Plus, I bet it's rarely just swapping one thing for another, right? It's like the whole system has to change sometimes.
Bingo. Having a cool invention isn't enough. You gotta figure out how it fits into the world, how people will buy it, use it. Sometimes that means changing the entire way an industry does things.
It's like realizing CDs are never coming back, right? Like MP3s changed everything. But someone had to invent the iPod first, the whole system, before it really mattered.
You got it. And you know what? The book actually gives a really good example of this whole old system sticking around thing. I call it the COBOL conundrum. Though that's my own little thing.
Okay, now you have to explain what is COBOL and what's so conundrumy about it.
So COBOL, right? It's a computer language, but we're talking like old school. I'm talking back when computers took up whole rooms, used punch cards.
But seriously, who's using that in the age of like Teslas and Siri and stuff?
Okay, ready for this? According to our source, almost 3%, a big chunk of the global economy still runs on COBOL code.
No way, really? Why haven't we ditched that for something, not from the dinosaur era?
Because, my friend, it's that. If it ain't broke, don't fix it. These companies, they've got co-systems, important ones most likely, and they're built on this old code. Might be clunky, but it works. Upgrading, that means stopping everything and retraining everyone. Huge cost, huge risk. Easier to just let it be.
I guess they wouldn't want to mess with it too much.
Exactly. And that is where those new business models we talked about come in. Sometimes it's not even about swapping tech. It's about realizing the whole way we do something has to change.
Makes you think, what are we using now that it'll seem totally nuts to our kids,
Totally. And speaking of things that are going to be huge, just think about data. The amount of data we have now compared to back then is on a whole other level.
Right? Data is the new oil, or so everyone keeps saying. But we need, the digital equivalent of oil rigs and refineries, don't we?
Exactly. Data infrastructure. That's the servers, the software, everything that takes all that raw data and makes it usable. Otherwise, it's just noise.
And that is not cheap.
Yeah, not for the faint of heart, that's for sure. Same as those train tracks back in the day. Data's great, but without the infrastructure, the systems, the whole shebang, it's useless. Takes time, takes money, takes everyone getting on board. We love the shiny new thing, but the foundation, the infrastructure, that's where the real revolution happens. And that, my friend, is why we look at history in the first place.
It's not enough to just, know how we got here. The cool part is seeing how those old patterns are repeating themselves now.
Exactly. It's like history gives us this cheat sheet for understanding why things change the way they do. Tech isn't just about inventing, it's about integrating. And that takes time, like serious time, decades even.
It's so tempting to think we gotta be on the bleeding edge right this second or get left behind. But history's like, chill out, dude. It takes longer than you think. So for someone listening who's like, okay, cool history lesson, but I'm not building railroads or whatever, what's the takeaway? Why should they care about all this?
Because whether we realize it or not, we're all part of this tech revolution, right? This stuff affects all of us. And knowing how it's played out before, that gives us a leg up. Honestly, helps us make better choices as consumers, workers, just people in the world.
So it's not even just about if I buy the latest gadget, it's about understanding the why behind it all.
Totally. When you get a new piece of tech, don't just think this is cool. Gotta have it. Ask yourself, what need does this fill? Is it actually going to be useful? What's it going to cost? Not just in money, but like how does it change things around it?
It's about being thoughtful, not just a consumer, which is awesome. And it makes me wonder, if big changes unfold slowly, what's happening right now that we're not noticing? What's the steam engine or microchip of our time just waiting to explode? Something to think about, right?
Yeah, totally. And it's wild to think that what we're seeing now with data infrastructure and AI, it's basically following the same playbook as those earlier revolutions. Makes you wonder what parts of today's tech will actually be the ones that matter 20 years from now, right?
Absolutely. Well, we covered a lot today. We discussed the first 4 characteristics of industrial revolutions, exploring how a single invention can lead to a new infrastructure and how interconnected innovations reshape our world.
Next time, we'll dive into the remaining 4 traits. We'll explore how societies often underestimate the time needed to adapt, the far-reaching impacts of these technologies once embraced, and the winners and losers that emerge in every industrial revolution. Plus, we'll examine the crucial role governments play in steering these shifts. Stay tuned for what's coming up next.